Section 5.4 is factor and solve polynomial equations. If you recall, when we factor, we simplify, and then solving, we just take whatever we simplify and set equal to 0. We'll do some examples of things we've done previously, and then go into some new shortcuts for factoring. Again, first one is a general trinomial. In this case, we do some reverse FOIL. So you build your pairs of parentheses, so your binomials. Let's see. So factors of 2, 1 and 2. Factors of 20 are 120, 2, 10, and 4, 5. And the 4 and the 2 get me 8. 5 and 1 gives me 5. And 8 minus 5 gives me this 3. So I have 2x, and I have x here. I can see my 2x squared. I have 4 here, 5 here. That's 20. The 4 gives me the 8. The 5 and the 1 here gives me the 5. The difference will give me the 3. It's a negative 8x, so I need negative 3x, so this would be a negative. It's going to make a negative 8x, positive. Next one's just a perfect square trinomial, and that is going to be x plus 4. It's 2 of them, x plus 4. And then always, simplify further to say x plus 4, that binomial squared. Difference of 2 squares, we've had a lot of these, and you're going to see many more. Fits the pattern of 3x minus 1, 3x plus 1. Again, this is difference of 2 perfect squares. One's a perfect square, 9 is, as well as the x squared. And it's always the difference, never a plus. Common monomial factors, quite simply just factor out what you can from both. A 4 comes out of 8 and 20, and one of the x, always take the smallest exponent. So we can factor out the 4x, so you have 2x plus 5. So those are things we've done previously. So again, when we're factoring polynomials, we're going to get down to the least factorable polynomials, or unfactorable. We get unfactorable polynomials. Keep going to the unfactorable. So we can do some further examples here for you quickly. Under example 1, so I see x in all those. So I'll pull out the x. So I have x squared plus 2x minus 15. Trinomial, so if I can reverse FOIL that, I think 3 and 5 will give me a 2. So I have x here, bring the x down. There's my 2 binomials, x, 3, and 5. The sign here is negative, so this sign goes to the bigger value, so it'd be a 5 and a negative there. Okay, next one, I have a 2 from both of these and a y to the 3rd power. I can pull out, so 2, y to the 3rd, leaves me y squared minus 9. This is a difference of 2 squares, so I can do 2y to the 3rd, that stays. My 2 binomials will be y minus 3, y plus 3. That's finished as well. Last one on this list, 4, I think I got a 4 from all those, and if z to the 4, z squared, so I can put a z squared. I'm going to write x. I don't like to write z's because sometimes they look like 2's, so I'm going to convert my variable to an x here. So I'll take out a 4x squared, and I know there's z's here, but bear with me. So this will become x squared minus 4x plus 4. Now, let's see this trinomial. This will fit the pattern of a perfect square trinomial, so it's 4x squared yet, whatever you remove as a GCF. This is going to be x minus 2, x minus 2. Again, you want to combine that into 1, so it's 4x squared, x minus 2, that binomial squared. All right, there's a new pattern in town, and it's for when you have the cube, sum of cubes. So you have some variable cubed plus some other variable cubed. Now there could be a coefficient with these and a bunch of other things as well, but each part of it must be a cube, including the coefficient. You can also have a difference of cubes. a cubed minus b cubed. And all you do is you jam them into these little equations. You mark whatever your a and your b is and put them in here. I'm going to show an example on the next page for you. So, here's a couple examples. The first one here, and they did a little extra work for you. It starts out as x cubed plus 64. Well, 64 is actually the same as saying 4 to the third power, 4 cubed. So you have x cubed, 4 cubes. So you have the sum of 2 cubes. So you'll be able to use that formula. Now here's a great time to show you another formula I have for you before we do these problems. Here's a attack strategy for doing factoring. And these are the steps you need, and I'll let you have this for your tests. And you can write anything else on here. In fact, I'll add a few things to this shortly that you can use. Again, you know when you're doing PEMDAS, get rid of the parentheses first. You combine like terms. That's easy. And also try to get into standard form. Always the highest exponent first and work your way down to the constant. All right, then it says always factor out GCF. So if it's 2x squared plus 4x, you can factor out 2x from both those terms. That's the GCF. Another key thing here, we haven't done much with this, but if you have a leading coefficient that's negative, take out a -1 so that all the signs change, and your leading coefficient will then be a positive. An example would be like negative x squared plus 9. Well, if I take out a -1 from that, times -1, I can make it x squared positive minus 9. Both signs will change. And now, that's easy to factor down to x plus 3 and x minus 3. Okay. All right, depending on how many terms we have, so a little further. Things we already talked about. If you have the sum of squares, well, you cannot factor it. Doesn't matter what they are. Will not factor. You're stuck with that as the minimal factoring. The difference we've covered already today and earlier, and it becomes the plus minus of the AB. Now, the two new ones. Sum of cubes. Again, ones we had earlier in the last couple sections, we had something like this where we had 2x minus 7 and the whole binomial was cubed. And we had a shortcut for that. But you didn't have to memorize it. You could have just done 2x minus 7 3 times the hard way and just gotten the answer from that as well. But look how each of these is cubed, not just the binomial. So you have a plus and a minus. And what you do is you just put whatever you have for A or B, you put it into these places here and simplify from there. When you're done, when you're doing these sum of cubes or difference of cubes, these trinomials will never reduce through inverse FOIL. You're pretty much stuck with that. Okay. All right, let's go back to try one, example 2. So they converted this. This is how the problem would come to you. They're just showing you go to cube, and it fits this pattern here. A cubed plus b cubed. So what you do is the a is going to be x, the b is going to be 4. So you're going to plug those into where the a and b are on that cheat sheet. So it's going to be a plus b, which is going to be x plus 4. That's a, that's b. And then it's a squared is next, so you're going to have x squared minus ab. Well, a is x, b is 4, so it's just going to be 4x. And the last term is b squared, which is going to be 16. Now the signs are given to you right in the cheat sheet. Don't try to bring a sign from here if it's negative pot. Don't bring those along in. They'll mess it all up. Just put these values in where they belong. The signs are part of the formula. And that's done. You can't reverse FOIL this. Yeah, here's one of these spaces here. This is a subtraction sign. You got to factor out first here. So I'm going to take out a 2 and a, again, I'm going to go to x because I don't like z's. So I'll take out a 2x squared. What's left here is 8x to the third. This is an x, and it's an x. Minus 125. Well, that's not real pretty, so you can convert these to cubes. So 2x squared. The 8 is 2 cubed. It's Still x cubed. And this is 5 cubed. We're not quite there yet. I got to convert this to an a. Well, that's cubed and this is cubed. So I can basically distribute those together. So it's 2x squared. The quantity 2x is now cubed minus 5 cubed. And now we have our a, which is 2x, and our b, which is 5. I can put them in the formula. Again, from this little cheat sheet here you have, here's a difference right here. Again, I just put the a, the b, the a squared, the a times b, and the b there. And keep these signs that are on this cheat sheet. So the first one is going to be a minus b, so it's going to be 2x minus 5. And over here's a squared, so it's going to be 4x squared. Because my a is 2x, my square root of 2 is 4, square root of the x, it's going to be x squared. The next one's ab, so it's going to be 2x times 5, which is going to be 10x. That's plus. And the last one's b squared, which would be 25. So even though this is negative 5, just bring the 5, just bring the 2x, and plug them into that formula. All right, good luck.